Next talk, otherwise we would have been run a bit late. Thanks for speeding us up. Next on stage, we have Igor Gulamov, founder of Zero Pool and Savante Chat. He's a security researcher and an AI engineer. Among others, he has audited 1inch and ARP. And today he's going to talk about beyond human review, the inevitable arms race between offensive and defensive AI. Welcome.
Beyond human review, the inevitable arms race between offensive and defensive AI agent. Igor Gulamov from Savante Chat. We start building our solution one year ago, in February 2025. We have some tasks, simple security tasks for AI. Like this. This is transfer function with vulnerability when from and to address are equal. Then the same memory slot overwrite twice, and we can mint tokens. And we tested it with GPT 3.5, with GPT 4, with GPT 4.0, with Opus 2, and so on. In 2024 and earlier, no one model can solve it. But in 2025, it happens, and with minor help, it can solve it. Then we decided to build the solution to find security vulnerabilities and help to protect projects from hackers. But hackers also weaponize AI. Here we see a value of hacks in 2025, beginning of 2026, and you know, April 2026 is best month forever for hackers. A lot of hacks, and most of these hacks are AI improved. We can see a lot of signs that the hacks during last year are AI approved, like some things like console log in attackers' contracts, or cross-domain hacks. For example, if we're speaking about binding hack or balancer hack, usually before we had cryptoeconomic hacks or some kind of access control hacks, and it was separate. But now the reality is that hacks could be cross-domain when exploit is built from multiple different domain area things, like PhD level mathematics from one side, and some smart assembly hacks from another side, that all together is going like one exploit. And it was very rare, very it wasn't in blockchain the market before, because I think Lazarus don't have a lot of PhD level people in math, but now it's reality because AI bring this level of math to black hats. Speaking about our solution, Savante Chat reproduce root cause of 100% vulnerabilities from August 2025. It doesn't mean that we reproduce the all exploit path, but the root cause, the theme, what could be fixed, and then exploit could happen. Also, there are some academic benchmarks and benchmarks from AI companies and independent researchers that the ability to find security vulnerabilities and all exploit paths is growing for AI models. Here this works. this is graph how internet is commodified and becoming cheaper. So here each line is an intellectual line. It began from state-of-the-art model, and next we have points with the same intellect models but cheaper models released later. And here we see a lot of lines. I think the last line is the cost is decaying more rapidly, but I think it's because we have only 2 points. If we will make if we check it in some months, we will see with hyperability it will be the same. So the cost halves every 1.5 months. It's not like more now, it's much faster. It's extremely fast. So that means that if we are speaking about 01 level, for example, the price is become 91 times cheaper during 9 months. That means that first you have a state-of-the-art model, you use it for to find security vulnerabilities, and you use a lot of hardness around it to make the request with the most efficient, reduce number of requests, use caching, advanced process engineering, and so on, to make your product to find vulnerabilities not so expensive but efficient. 9 months passed, and what do? You do the same intelligence models to mark text in the code base. To slice, for example, with smart chunks later. So you use it as the cheapest commodity on the market. So here are some results from ETHPrague, also for LLMs and meter. We see that model can do big chunks of job independently and get high results as SVE. This SVE is important for building proof of concepts, not for finding the things, but for verifying it, for example. Hardness is also important. For example, we built a CTF bench in February 2025 to measure abilities of AI, to find security vulnerabilities and measure the noise level. Because if you have very high noise level, you can have very nice insights about vulnerabilities, but you cannot use it if you have 1,000 slope reports items per one signal report. We measured event bench, agent from paradigm, and also agent Lisa and some other solutions, and find out that very often the solutions can find something, but the solutions are far from state-of-the-art. For example, the event bench is free and public, and it's working fast for minutes, not for hours, but it finds only 4 from 7 issues in CTF bench, and speaking about agent Lisa, also haven't find bug in token contract. I showed before the transfer function with vulnerability. But the transfer function with vulnerability with valid hardness is solvable with DeepSeeker 1 on February 2025, and all the CTF bench will be solved in June 2025 with GPT 2.5 Pro. So Gemini 2.5 Pro. Here is CTF bench, how it's working. On x-axis we have rate of reports per line of code according to clock. And high number of reports means high noise, lower is better. On y-axis we have share of detected vulnerabilities. So we have 4 contracts with no vulnerabilities and measure X report index on it, and 7 contracts with vulnerabilities and measure ability for models to find these vulnerabilities. And we find that now we have ETHPrague is solved by GPT 5.5 and Gemini 3.1 product. And speaking about cloud models, if you're scared about mythos, I think in the market there will be more powerful models which can find more security vulnerabilities. We see now GPT 5.5 show better results on ETHPrague and find out of the box all the issues. Speaking about our harness, it is ultra quiet. You see it can report one vulnerability per 200 lines of code. It's very low. But from another side, it's solved with ETHPrague in June 2025. This is CVM bench. We do it some days ago. And here are results. We have lower limits of it for our solution because we run our agent only on scope where code is situated. It looks like cheating, but it's cheating to another side. Because in production, our agent take each chunk of code and make wide research from different angles. And in this research, in this check, we do it only from one angle. Why? Because it's expensive, and this approach gives us way to spend only about 1% of inference, but anyway, the cost is valuable. This is how harnesses work. So on the input we have source code and documentation. Next we extract samples, using rack, chunking, and so on. We make samples, and next we make deep research on each of sample of code and documentation. On the last check, we also use database of vulnerabilities. We use it from 20,000 known issues. I will tell later about it. Next, let's go into critic sub-agent, and critic is filtered more than 95% of hypotheses. Then we remove duplicates and redirect. So this is about working with data to make some kind of university textbook about vulnerabilities, but for AI. We take 20,000 vulnerabilities, select 6,500 from it. Next, each vulnerability will be distilled from project specific and only write small, like academic examples about how this kind of vulnerability is going in which kind of contracts. Next, we make clustering on it, and that's how this data engineering going. This is a map of these classes. So this map is obtained fully automated. So it could be done not only for Solidity but for any area, for Rust, for C++, and other languages. And this approach increases performance from 20 to 50%. As ability to find vulnerabilities. It's working like senior auditor when senior auditor is working with IMM, for example. He can remember how previously such kind of smart contracts were hacked, and that's how it's going. Also, critic subagent is also important because if we have a lot of noise, it's hard to work with this hypothesis, and we reach results when fixed rate in our report is more than 50%. If the code base is not hardly audited and fixed before. Let's talk about economic asymmetry between black hats and white hats and auditors. So, for example, we have some kind of $1 million jackpot. And black hat, if hack it, he can just drain this $1 million. And that's important. What is the price of this attack? To find this vulnerable contract, the black hat should earn, for example, $100,000 for inference. A lot of wide research and also the valuable part for deep research to build the whole exploit path from broken invariants and all of these things. But of course, if we're speaking about white hat hacker, the reward for bug bounty on $1 million smart contract will not be 1 million, it will be some tens of thousands of dollars maybe. And if the cost to find this vulnerability is $100,000, the economic is not working for white hats. So that is the issue. For now, we know a lot of AI improved white hackers because the market isn't stabilized for now, and as far as I know, the problem of building exploit path is not 100% automated yet. But when it becomes fully automated yet, then economics factors will be more heavier than factors of personalities of actors on the market, and that's the problem. And what is the solution? The solution is preventing the hacks by audits. Because auditor can work with more weak security assumptions. For example, if auditor will find out the broken invariant, it could be broken for some ways, it doesn't matter. Auditor will highlight it, that invariant is broken, and third parties can take some ways from another people balances. And that's enough to fix it. Why? Because if all invariants are okay, then there is no area to make attack for $1 million damage. And finding broken invariants and such things is a more easy problem, and for now it's 100% automated by AI. So these are three roles. Auditors, black hats, and white hats. what is going next? First is agentic loop. So before we have retry and verify things when we just our models just read the code and make assumptions, hypotheses, and check it. But now we can make experiments with code. So we can write experiments and execute it and get feedback about it. It is possible some months ago in software engineering, but if we are speaking about auditing and finding security vulnerabilities, it's wide research, it's not deep research. So we need more inference, thousands times more inference to do it, and now it's become possible. Before, theoretically it could be possible, but it costs $millions. But now it's possible with you can write scripts what to check to models like Minimax and 7 and it will work. Such things become possible. Next is formal verification. Now AI can write formal proofs in things like the Torah or Hamas. And what does it mean? It means that AI agent can ask a code base with high-level questions. So, what happens with this invariant if something is going wrong? And this approach will reduce inference a lot and reduce hallucinations also a lot. And next is model orchestration. We already have model orchestration. We use cheap models to mark the code base, to slice it chunks and find related documentation. But now we have very big gap between super smart models and super cheap models, and there are a lot of grades in it. And that means that we should use next level of model orchestration with different grades of tiers of LLM intelligence and tasks for them. So we don't need PhD level math or economics on each request, but we need advanced orchestration between all these models. Speaking about what is in production, so the orchestration, proof of concept building, it's automated, and we are working actively on implementing formal verification. Speaking about future security stack, here is how it's going. On the first step, it should be some kind of static analyzers, next AI scanners, and next proactive defense, and next human auditors for business logic and architecture. The race is not end, and it's important to understand that if we are speaking about auditors and AI and white and black hackers, we have two separate domains of vulnerability: human domain and AI domain. And this is parallel track, separate story. In each domain there are weak, simple vulnerabilities and hard vulnerabilities which are very hard to catch, and these are parallel tracks. To be safe, anybody now should use state-of-the-art AI tools to protect from AI black hats and best human auditors to protect from best human black hats. Thank you for your attention. If you have questions, I can answer.
We have maybe one last question from the audience before we continue. Otherwise, I'm sure people can also find